Assalamu alaikum. Welcome to my YouTube channel. In this video, we learn about the mechanism of enzymes and mechanisms of enzyme action. Enzymes are a powerful catalyst. The nature of catalysis taking place in biological system is similar to that of non-biological catalysis. For any chemical reaction to occur, the reactant have to be in activated state or in transition state. The next is enzyme lower the activation energy. So let's discuss the enzyme required by the reactant to undergo the reaction is called activation energy. The reactant when heated attain the activation energy. The catalyst reduce the activation energy and this causes the reaction to proceed at lower temperature. Enzymes do not alter equilibrium constant, they only enhance the velocity of the reaction. The enzymes produce an activation energy of the reactant in such a way that all biological systems occur at a body below 40 degrees centigrade. Here you can observe activation energy with enzyme and energy released by the reaction. Enzyme substrate ES complex formation. When the substrate combine with the enzyme at active site to form enzyme substrate complex, which ultimately result in the product formation and form enzyme substrate complex. Models of enzymes. Enzymes basically has three models: lock and key model, induced fit theory, substrate strain theory. So let's discuss lock and key model. This theory was proposed by German biochemist Emil Fischer. This is in fact the very first model proposed to explain an enzyme catalyst reaction. According to this model, the structure or conformation of the enzyme is rigid. The substrate fit to binding site just as key fits in proper lock or hand in proper glove. The active site of an enzyme is rigid and reshaped template where only a specific substrate can bind. Active site should have specific shape and charge. Here you can observe lock and key model. This model totally fails to explain many facts of the enzymatic reactions. The next is induced fit model. Koshland in 1958 proposed a more acceptable model for enzyme substrate complex formation. The interaction of the substrate with the enzyme induces conformation change in the enzyme, resulting in the formation of a strong substrate binding site. Here you can observe substrate enzymes and enzyme to substrate complex and product of enzyme. Induced fit model has experimental evidence from the X-ray diffraction studies. This model explains the competitive inhibition on enzymes. Here you can see lock and key model hypothesis and induced fit model. Substrate strain theory. In this model, the substrate is strained due to the induced conformation changes in the enzyme. It is possible that when a substrate binds to performed active site, the enzyme strain to the substrate. Enzyme substrate, enzyme transition state, enzyme plus product. Mechanism of enzyme catalysis. The formation of an enzyme to substrate is complex critical for the catalysis to occur for the product formation. The enhancement in the rate of reaction is mainly due to four processes: acid-base catalase, substrate strain, covalent catalysis, and anatrophy effect. Acid-base catalysis. Role of acid-base is quite important in enzymology, and the physical pH histidine is the most important amino acid. As you can learn more through this. Acid-base catalysis is given in diagram, mostly understood by oxidoreductase enzyme. Substrate strain. Induction of a strain on the substrate ES formation. During the course of strain induction, the energy level of the substrate is raised, leading to the transition state, the mechanism of lysozyme action. Covalent catalysis. In the covalent catalysis, the negatively charged nucleophilic and positively charged is present on the active site enzyme. This group attacked by the substrate that result in covalent bonding of the substrate of the enzyme. Here, the covalent catalysis given. Proximity catalysis. The reactant should come in cross proximity to the enzyme for appropriate catalysis to occur. The higher concentration of the substrate molecule, the greater will be the rate of reaction. Catalysis by proximity. You can observe in diagram. Don't forget to subscribe my YouTube channel. Thanks for watching video.